We're going to take a look at the different types of adaptive immunity and introduce vaccines in this lecture. It's really important to know the difference between active and passive immunity for the test. So active immunity is when your immune system is stimulated to react. So the B and T lymphocytes find their match, they start dividing, and they do produce memory cells. So memory does develop, and the memory cells can last the rest of your life. Or with some other pathogens, they may not last quite as long. So for example, we need to get the tetanus vaccine every 10 years. Passive immunity is when your immune system does not react. So you're going to be given antibodies made by someone else. So because your immune system was not stimulated to react, no memory cells develop and there's no memory. Passive immunity, these antibodies you got from someone else, may only last a couple weeks to a couple months. So make sure you start this slide and the next one because I will be asking you these on the exam. So the first one, naturally acquired active immunity. So this is active immunity. We're going to stimulate your immune system to react, and your B and T lymphocytes will divide and you will form memory cells. So how this is naturally done is if you get sick. So an example might be maybe you get the chickenpox or you get the flu. So that would be an example of naturally acquired active immunity. And memory does develop, so we'll put memory yes. Naturally acquired passive immunity. Passive immunity means your immune system is not stimulated to react. You're going to be given antibodies made by someone else. And there's two ways that this naturally happens. So one is mom can pass the IgG antibodies across the placenta to the baby. And then the second one is that after the baby is born, the breast milk, that first colostrum, contains lots of IgA antibodies. And so those IgG and IgA antibodies made by mom will protect the baby for the first 2 months of life. And then after that, mom's antibodies start getting broken down and disappear, and then we need to start vaccinating the baby. Okay, next we have artificially acquired active immunity. So anytime you see artificial, you know that a needle of some sort has been involved. So this is active immunity. So we're going to stimulate the immune system to react. B and T lymphocytes find their match, and they will divide and produce memory cells. So an example of artificially acquired active immunity would be getting a vaccine. So maybe you got the flu vaccine, or maybe you got hepatitis B vaccine. So there's all kinds of examples there. And memory would be yes, because you will stimulate your immune system to divide and develop memory cells. The last one is artificially acquired passive immunity. So passive, meaning we're not going to stimulate the immune system to react, and we're going to be giving the person antibodies made by someone else. And this is going to be artificial, so this is going to be giving the antibodies with the needle. So some examples would be giving the person antitoxin or antivenom or an immunoglobulin shot. So we're just giving antibodies that someone else made, so your immune system is not going to be stimulated. So no memory cells will be made, so memory would be no for artificially acquired passive immunity. So here's just some pictures of artificially acquired passive immunity. So antitoxin is you're going to be giving an antibody that is going to bind to the bacterial toxin. So the antibodies are called antitoxin. So you would inject those antitoxin antibodies into the person who is suffering from, for example, like maybe tetanus or botulism. Those diseases are caused by toxins produced by bacteria, and so we can treat those diseases by giving the patient antitoxin. Antivenom is antibodies that are made against snake venom. So maybe you got bit by a rattlesnake and went to the ER. So they would inject you with antibodies called antivenom that will bind to the snake venom and prevent the snake venom from causing further problems for you. And then the last example of artificially acquired passive immunity would be an immunoglobulin shot. So let's say, for example, that you got exposed to hepatitis B virus, and maybe they're not sure of your vaccine status, or maybe they're not sure the vaccine is still providing you protection. They would give you immunoglobulin, so antibodies that are specific for that hepatitis B virus. And so they would inject you with the immunoglobulin, those antibodies, and that'll protect you from the virus entering your liver cells and causing damage. So there's a number of diseases that we can treat with immunoglobulin shots if you happen to get exposed to them. So rabies would be another one, RSV virus, respiratory syncytial virus in infants and children. We can also treat with that too. Here's a picture of what happens when you give a person a vaccine. So this is an example of artificially acquired active immunity. With the vaccine, we're going to give the person either a weakened or killed pathogen or maybe just a piece of the pathogen. That will stimulate a primary immune response. Remember that first time you're exposed to something, it takes about 10 days for the B and T lymphocytes to divide, produce those effector cells and memory cells. So what's important is that you're making these memory cells. And remember, those are long-lived cells. And so those memory cells have already been made. So if you are actually exposed to the real pathogen later on in life, those memory cells will react very strongly and quickly, and then you won't get sick. So that's how vaccines protect you. And then here's just a summary of the active and passive immunity, whether it's naturally acquired or artificially acquired. So make sure that you can give me an example of each of these, because that's very likely to show up on the exam. Let's take a look at the history of vaccination. Variolation, this was the first way that people were protected against smallpox. What they did is they would take the pustule scab material from a person infected with a mild case of smallpox, and then they would administer it to the person two ways. So either they would blow the dried scab material up the person's nose, which sounds really gross, or they would make a mark on the skin and then rub in the scab material into the skin. So they would actually give the person smallpox. The hope was that you would get a mild case of the smallpox, you would survive, and then you'd be protected the rest of your life. Unfortunately, there were some people that did die and got a severe case of smallpox from the variolation. So Edward Jenner came along in 1796. He was an English physician, and he decided there had to be a better way of protecting people against smallpox than using variolation and actually giving the person the disease. So he came up with the first vaccine for smallpox. He noticed in his village that the milkmaids never seemed to get smallpox. So in talking to them, he figured out that they had all been infected with cowpox. Cowpox is a virus that is very similar to smallpox, but just causes very mild pustules on the hands of people that would get the cowpox. So he decided to take a sample of the cowpox scab material, and he grabbed his gardener's son and made a mark on the child's upper arm and rubbed the cowpox material in there. The boy developed cowpox, but then he recovered. And then a couple weeks later, Edward Jenner exposed the boy to actual smallpox. And luckily for the boy, Jenner's vaccine worked. And that's very unethical. We would never do that today, but that's what he did. So that was the first vaccine that was developed. So he was actually giving people cowpox, which would protect them against smallpox. And the word vaccine, vaca means cow, so that's where the name vaccine came from. And then remember talking about Louis Pasteur. Remember that he discovered attenuation. So attenuate just means to weaken. So he figured out that if he grew the bacteria or viruses in unfavorable conditions, the bacteria and viruses would not be able to cause a severe disease, and so he could develop vaccines from them. So he developed a number of vaccines.